Hello everyone. In this video, we are going to solve one more example under the fluid in rigid motion. And in our previous videos, we solved about 2 questions, which this is going to be our third question that we are going to solve on. If this is your first time watching this video, I would like you to also subscribe and turn on your notification bell for more videos. Let's move on to our question. A 3-meter diameter vertical cylindrical milk tank rotates at a constant rate of 12 RPM. If the pressure at the center of the bottom surface is 130 kilopascal, determine the pressure at the edge of the bottom surface of the tank. Peak density of milk to be 1,030 kilogram per meter cube. So we are to determine the pressure at the edge of the bottom of the surface of the tank. So to start with our question, we are to draw our free body diagram, or we are to draw a diagram that illustrates whatever is here on the board. And this is how the diagram is going to be. Since it's a cylindrical tank, we have to draw something that looks like a cylinder here. And it's a free surface question, so we'll have maybe a liquid filling up the container. We have this here. And this is going to be our change in H. And this vertical plane, which is our Z, is where the cylindrical milk or the milk would rotate. And this is our point at which it will rotate. This being our R and our diameter being 3 meters. Now our original height, which was not given, HO, we represent it by HO, and also the height for the free surface, which is ZS. So now we are to determine the pressure at the edge of the bottom surface of the tank. Now they've given us the pressure at the bottom surface. That's the pressure here. And we are to determine the pressure of the whole system that has been drawn here. So to determine that pressure, so let's represent that by P, the pressure at the edge of the bottom. It's going to give us the pressure at the bottom surface. That's P. Let's represent that by ES plus the pressure at the free surface. That's here. There will be some pressure exerted here. So that's going to be P. Let's name it FS, the free surface. So we know this, but we are left with this, so that we'll just add them and find the pressure at the edge of the bottom surface. So how do we go about this question? This is the only information given to us. Also, we've been given the constant speed, that's N, to be equal to 12 RPM. We change it to omega. That's going to give us 2 pi n over 60, which is equal to 2 pi times 12 over 60, which is 1. So we'll get 1.257 rads per second. So now, to find for this is our problem now. So we have to find for this. And to find for this, we know for a free surface, our ZS small r is equal to H naught minus omega squared over 4g multiplying big R squared minus 2 times small r squared. Now let's make this analysis. Since the rotation is done on the z-axis, we know that r will be equal to 0, small r will be equal to 0, and z will also be equal to what? 0. So in knowing this, we can cancel out certain stuff here. So we can cancel this. Say this small r is going to be 0. We can cancel this, which will be left with r is equal to H naught minus omega squared over 4g big R squared. So we can also find for the big R, the free surface for the big R. So Z S big R is also going to be equal to H naught plus omega squared big R squared over 4g. So this is what you are also going to get for the big R. Now, to find for your delta H here, is going to be delta H is going to be equal to the ZS big R minus the ZS small r. So this would give us the big R is this. So we substitute that there. Minus the big S small r, which is this. So let's name this equation 1, equation 2. So H naught so in this, certain things will go out and it will be left with over 2g. So this is what it will be left with now. Since this will go out and this will become plus omega squared r squared over 4g. If you add it to this, you will come and get this component here. So this is our delta H here. So let's try to find our delta H. So delta H will be equal to the omega we found for it here. So that's going to be 1.257 squared times our r. They give us the whole diameter to be 3, so the r will be what? 1.5. So times 1.5 squared all over 2 times the acceleration due to gravity. So this is going to give us 1. So you are going to get 0.1814 1 meters. That's what you are going to get for the delta H here. So after getting that, we can easily find for the pressure. So we know that pressure for the FS, the free surface, is going to be rho G change in H. Now let's clean this here. And we have our rule, which is the milk here. We have it to be, let me write this again. We have it to be 1030 kilogram per meter cube times 9.81 times the H we had here times this H, giving us so it is going to give us 1828.88 Pascal. We convert it into kilopascal. It's going to give us 1.829 kilopascal. But we are not done. We've just found for this. So therefore, the pressure at the edge of the bottom is going to be equal to the pressure at the bottom surface. That's 130 kilopascal. 130 kilopascal plus 1.829 kilopascal, which is going to give us 131.829 kilopascal. So this is the pressure at the edge of the bottom surface of the tank. This is how we go about this question.